Okay, so you may have heard this before. Venn diagrams. V-E-N-N. Diagrams. These are very useful tools for probability problems. Okay? So, typical Venn diagram, and when I draw it, you'll probably recognize this, okay, is a couple of circles that overlap. Alright? And the probabilities are distributed throughout these sections of this diagram. So we'll call this, if we call this circle, let me do this in another color here. Let me do red over here. We can call this circle something like sports, and the other circle something like
Arrow.
well, yeah, so they would be two things that would be not mutually exclusive from each other. Okay? So this is the red. You could think of the red as, oops, let me get red, as the red equals the probability of A. Alright? And the blue circle would be the probability of B happening. Now there's an overlap here though, okay? So this overlap here, this section here, that's P what? A and B. A and B, okay? Now, so you got to be careful when you're putting numbers into these. You're always going to start with the P, A, and B number, okay, and put that in the middle there. And we'll do an example in a minute. But because this section here, let me get my red. This section here, we don't want to put the probability of A right here. We want to put the probability of A, but not the part that's overlapped, so that we don't have any overlapping in our numbers. Okay, so you got to be careful when you put in the numbers, and it'll be a lot more clear when I do an example. Okay. By the way, this out here, the rest of the space in the box is what?
Not whatever.
Yeah, that's P of not A, not B. So neither one of them happens. Okay. Yes. So let's do an example. Okay. So, in a school, 54,
Not a very large number.
54% of kids are girls. Alright? 62% of all kids play sports. Half of the girls play sports. Okay, and so that's some information. Then there's going to be some questions. All right, I'm going to put the questions. I'll put the questions over here. Let's see. Probability that a random kid is a boy who does not play sports. Okay, and then B. This could be all sorts of questions that could be asked off this information. Okay, we're just going to do a couple here. What percentage of kids who play sports are boys? Okay. So now, if you just read this, 54% of kids are girls, 60% of all kids play sports, half the girls play sports, and then you ask for the probability that a random kid is a boy who does not play sports. You can maybe figure that out without a diagram or whatever, but a diagram makes it much easier to figure this stuff out, especially if you have multiple questions about the same problem, because you can get all the questions off the diagram. Okay? So we're going to draw our diagram here. Alright? We're going to put our 2 circles. You can actually do this with 3 circles if there's 3 situations. Okay? So, now, put the overlap in first. Alright? Put the overlap in first whenever possible. Alright? So, we want to put numbers in here. We know that 54% of the kids are girls. We know 62% of the kids play sports. Half of the girls play sports. That's what's the number we can fit in this overlap. Okay, half of the girls play sports. So let me label these a little bit. So we got girls over here, sports. So where they overlap will be both. All right, but can we put a number in there? What can we put in the center part here? Half of the girls. The girls is 54. Okay, so half of that would be 27%. All right, let's put it in decimals. Okay, so that would be 27%. All right, or 0.27 is the overlap, because there's 0.54 is girls, all the girls. Half of them play sports. All right. Now this isn't going to be drawn to scale usually, but so if that's 0.27, now we want to put a number here. All right. Where the girls, this is going to be this space right here is girls who don't play sports, which is going to be what? So the other 27, right? So if you look at this entire circle here, all the way around, that's all the girls, and that adds up to 54%, which is what we want. Half of them play sports, and half of them don't. Okay, and that's the 27 and the 27. Okay. Any questions on that? Now the reason why you want to put the middle one in first, though, is because a lot of people want to just jump in and say, and put the 54, put the 0.54 right here on girls. Okay, you don't want, on this space right here, this space, you don't want the entire, girls. You just want the girls who don't play sports. Okay, so you got to be careful about that. Don't just put the 54 in for girls. Put the overlap in first, and then subtract to get what's left. All right? Yeah.
On a question like this, would it be acceptable to say there are 100 students?
You could. Yeah, you could.
So just put the numbers for them.
Yeah. Okay. So now we got to fill in this other section over here. This section is going to be boys, right? Because it's not girls, so it's got to be boys who do play sports. All right. So we have 62% of all the kids play sports. Right? Well, we already have 27 of that filled in. So what's left from that is going to be 35. Okay, this 35 and this 27 add up to 62. So that's your total sports. Okay, and now we've got 3 things here. That doesn't add up to 1 yet. So whatever's left is on the outside. Okay? So this is 0.11 right here. You can do that by adding those up, subtracting it from 1. Okay? And that'll give you this. And now that all those numbers are filled in, we can answer any of the questions about it. So the probability that a random kid is a boy who does not play sports, now it's easy, right? Because we just look at the diagram. Where are the boys who don't play sports? They're on the outside of the whole thing. No sports, okay, and no girls. This is girls, this is sports. It has to be outside of that, so that's your 11%, okay? So that's 0.11.
If you have 3 questions, will you end up where it doesn't add up to 1? Or does it always add up to 1?
No, the whole diagram should always add up to 1. Yeah. Okay, and then we have, so what percentage of kids who play sports are boys? Well, this is a little bit more now. We have, what's the percentage of kids who play sports are boys? There's 2 things going on there. So what's the percentage of kids who play sports?
30.
Overall. 62. It's 62. Okay? But 0.35 are boys who play sports. So if we want to know the percentage of the kids who play sports that are boys, Okay, we're not looking at it. That's a different question than how many of all the, or what percentage of all the kids are boys who play sports. This is different. That's a different question. This is specifically what percentage of the kids who play sports are boys. So it's 0.35 out of 0.62, all right? And that would come out to 56%. Okay. Any questions on it? Yeah, we're.
I don't understand why you came up with question two. I thought we would have been by now that we put question five.
Right. If the question said what percentage of all the kids are boys who play sports, then the answer would be 0.35. Okay, if that's what the question said. But that's not what the question is saying. This question is saying what percentage of kids who play sports. That narrows it down already to your 62%. All right, that's all you're drawing from, because that's saying of those kids, the percentage of those kids that play sports, or I'm sorry, that the percentage of those kids that are boys is going to be your 0.35. Okay, out of all the kids who play sports, which is 0.62 already. It's slightly different. Right? That's okay. We'll have a little practice with this stuff. Okay. I'm going to stop that there actually and continue.